Hello everybody, so today we're going to be talking about section 2.5, which is inequalities. And yeah, let's get right into it. So we have a couple of theorems / properties. So yeah, so the first property is, or no, it's not even a property, it's just a definition. These are all definitions. These four. So bad. These four are all definitions. So yeah. So first definition is if A is less than B, it means A is less than B. Yeah. So the next one is if A is less than equal to B, it means that A is less than equal to B. Really, all you just need to know is what these signs mean. If you know what these signs mean, then you're basically good to go. So this first one is less than. The second one is less than or equal to. The third one is greater than. And the fourth one is greater than or equal to. There's supposed to be a colon right there. So a definition. Algebraic inequalities contain one or more variables. So a solution set for an inequality can be shown like this. So this one is x is less than 2. The solution set is like that, and then the graph is like this. It has a bracket and then parentheses, and then it goes like that. So the reason it has parentheses is because it is less than. Now if you went ahead, then you can see that in the x is greater than or equal to 1, then you can see they used a bracket instead of a parentheses. So using context clues, you can probably figure out that when it has the greater than equal to or less than equal to, it has these brackets, but if it's less than or greater than, it has these parentheses instead of brackets. And the same thing is applied when you're using interval notation. So this is basically what interval notation is. So the graph shows that it's from 2, but not including 2. So that's what the parentheses mean. That it's not including 2. It's less than 2, but it does not have 2 in the solution set, and the solution set goes all the way to negative infinity for this top one, for x is less than 2, and for this one, it goes to positive infinity. That's why they have infinity over here and then negative infinity over there. And whenever you're using infinity, you never use these brackets. You always use parentheses when you're trying to use infinity or negative infinity. Okay, so that should be good for that one. Okay, so moving on to example 1. Express the given inequalities in interval notation and graph the interval on a number line. So I'm going to do the graphing first. So make a number line. Make sure you put the arrows. This is going to be the 0, 1, 2, 3, 4, 5, 6. Since it's greater than, we know it's not going to go into the negative, so I will not bother to put in the negative for the number line. And one way you can graph it is by putting the parentheses like they show, and then putting the line. Another way you can do it is, instead of doing the parentheses, you can just do an open dot, and if it's a greater than equal to or a less than equal to, then you would do a closed dot. You can do it either way. I really have no preference. So if I do an open dot, just remember that it doesn't have the bar below the greater than or equal to, the greater than or less less than sign. So it's like this. I'm just gonna do it like this for this one. Okay, so now for, oh, I forgot to do the interval notation. Okay, that was weird. So x is greater than 2, you would do this, 2, and then infinity, parentheses. So it's parentheses, I explained it in this one with the greater than, less than, and then you start with 2 because it's greater than 2, so yeah. And then now we're gonna move on to the second part. So x is less than equal to -1. So we can see that we have a less than equal to, which means we either need the brackets or the closed dot. So in the number line, we know that we're going to go into the negatives, so I'm only going to do the negatives. My spacing is definitely not even, but that doesn't really matter right now. So it is less than or equal to -1. So I'm going to do a closed dot for this one. And then draw the line. You could also do the bracket if you really want. The interval notation for this is parentheses, -infinity, comma, what is it, -1. That is the interval notation for this. Okay, so example 2. Now we have a algebraic problem. So what I like to do when I have an algebraic problem, before I got used to inequalities, I used to pretend they were an equal sign, and then I would just solve them simply like this. But there is a slight problem when you're doing this with the equal sign. When you're multiplying with a negative number, so say it's 1 over -1/2x is greater than 4. So say this is some equation that we have to solve, and don't do an equal sign. I would recommend that you do not get a habit of using the equal sign, because there can be some problems like this where you have to multiply with a negative number, and then that gets you, when you multiply with a negative number, you have to switch the sign to a different, to the opposite. Like, so in this one it's greater than, we multiply it with a -2 to get a positive x, and then you would get x is less than -8. So that would be your solution for this equation. So keep in mind that when you're multiplying with a negative number, you always want to switch the sign. So now let's move on to this one. So I don't think in this one we don't have to do any switching. So we just solve it like a normal equation. We add 4 to both sides. We get 3x is greater than 12. Divide 3 to both sides. We get x is greater than 4. Now moving on to example 3. Well, actually, you know what? We'll graph this and put it in interval notation as well. So number line. I know I'm not going into the negatives, so I'm just going to do this. 7 and then 8. So it's greater than 4, which means you can do an open dot or parentheses, whatever you like, and then draw the arrow, the line. And then interval notation is parentheses 4, comma, infinity, parentheses. So our next example, we have -3x plus 5x minus 2 is greater than or equal to 8x minus 7 minus 9x. So we're just going to simplify both of these sides separately. So for this one, we get -3x plus 5x, which is a positive 2x. We have no more numbers. Put a greater than equal to sign. Simplify it. we get 8x minus 9x, which is equal to negative x, and we have negative 7. So now we just simplify it, add an x to both sides so that we can cancel out this x, and then add 2 to both sides so we can cancel out the negative 2. So we get 2x plus x is greater than equal to negative 7 plus 2. So we get 3x is greater than equal to negative 5. Now we're going to divide both sides by 3, and we get x is greater than or equal to negative 5 by 3. So the interval notation first. So we have negative 5 over 3. Oh, whoops, I forgot that it's a bracket, comma, infinity. And then put the parentheses after the infinity. Okay, so now we're going to draw the number line. It is going into the negatives, so I will put a 0 closer to the left side because it's not going that far into the negative. It's in between negative 1 and negative 2, obviously. 1, 2, 3, 4, 5, 6. That should be good enough. So now this is approximately, it's close to 2, so I'm just estimating that it's going to be somewhere around there. And then we just draw the line, or you can do the closed dot if you want. Closed dot. Sorry for that really weird line. Okay, example 4. So solve 3 times 2x plus 1 minus 2 times 2x plus 5 is less than 5 times 3x minus 2. So we're going to simplify both of these sides individually, like we did in the last problem. We're going to use the distribute property, and we're going to get 6x plus 3 minus so minus 4x and then minus 10, which is less than 15x minus 10. I forgot the x there. Now simplify the left side so that it's easier for us. We're going to get 2x minus 7 is less than 15x minus 10. So in order to not switch the signs, we can bring the 2x onto the right side and move the numbers to the left. So that's what we're going to do. We're going to subtract 2x from both sides and add 10 to both sides. And that's going to get us minus 7 plus 10 is less than 15x minus 2. We're going to get positive 3 is less than, I forgot that x. Positive 3 is less than 12x. I'm going to divide both sides with x. Well, actually I could switch it around. I'm going to do 12x is less than, or is greater than 3, because that's basically what it is. It's 3 is less than 12x, 12x is greater than 3. So then x is greater than 3 over 12, which is equal to 1/4. Now the interval notation for this is parentheses 1/4, comma, infinity, parentheses, and then let's draw the number line. We're nowhere, well, we are near it, but we're not going to be in the negatives, so I will put the 0 closer to the left. 1, 2, 3, 4, 5, that should be good enough. Okay, so 1/4 is 0.25, which puts it somewhere around here. And that's the open dot, but if you wanted to do the closed dot, or not the closed dot, but if you wanted to do the parentheses, you would do it like that. Did you catch my mistake? Yeah, it was that I did a bracket instead of a parentheses. Kind of looks like in here. Okay, so next example. we have 4 times x minus 3 is greater than 9 times x plus y. So we're going to solve it like, we're going to use the distributive property and simplify both sides. So we have 4x minus 12 is greater than 9x plus 9. And then we're going to bring the x's over to the right side because I do not want to do, I don't want to multiply anything with a negative number. So we're going to subtract 4x from both sides and subtract 9 from both sides. So that's going to lead us to negative 12 minus 9 is greater than 9x minus 4x. So now when we simplify both sides, we're going to get negative 21 is greater than 5x. I'm going to get x is greater than, oh we know x is less than, sorry, that was my bad. X is less than negative 21 over 5, and that is our answer. That's our solution. So putting this in integral notation, you get negative infinity, comma, negative 21 over 5, and then parentheses. Now I know that we are in negatives, so I'm going to put the 0 closer to the right. Now negative 21 over 5 I know is more than a negative 4, because 5 times 4 is 20, so 5 times 4 point something. It's definitely closer to negative 4, which will that'll lead us to 21. So we're going to use a black pen to contrast with the red. Now this is once again going to be an open dot or a parentheses, and then that's it. Other way is the parentheses, and there you go. That's the line. And that's it for this lesson, 2.5 inequalities. If you like this video, a like would be appreciated. If you want to support the channel, a sub would also be appreciated. Feel free to contact me with the email that is given on the screen if you need any help. Otherwise, I hope you have a great rest of your day.